So when I'm given a rational function, particularly a rational function which I'm supposed to integrate, I'm going to bank on the fact that every rational function is a fraction of two probably different polynomials. And I will call them P of x and Q of x. So the very first thing I'm going to do is I'm going to check the degrees of these two polynomials. So remember that the degree of a polynomial is just the highest power of x that we can find. And we want the polynomial on the top to have degree smaller than the polynomial on the bottom of the fraction. You'd call that a proper rational function. So if I don't have that, so this is just the definition of degree in the phrasing of the book. So highest power is x to the n, coefficient is not 0, so there's your degree formula. If you have an improper fraction, improper rational function, then that's when the degree of the numerator is greater than or equal to the degree of the denominator. And what you're going to do in that situation is you're going to do long division, just to get rid of those extra powers. So there's sort of a preparing step. And if you do the long division correctly, you'll get just a good old regular polynomial. They are wonderful to integrate, plus your new rational function, and we're calling this r of x divided by q of x. So, okay, that's very abstract. What does that actually look like? Here, we've got an antiderivative or an improper integral. Take your pick. The function we're looking at is x cubed plus x divided by x minus 1, integrate with respect to dx. Now, this is exactly the situation I was talking about. It's an improper rational function for the fact that I've got degree 3 on the numerator and degree 1 on the denominator. So we're going to need to do long division, and sadly they did not write out those steps on these slides. The claim being that after you perform long division, this rational function x cubed plus x divided by quantity x minus 1, that will be equal to a quotient, which is just a polynomial, of x squared plus x plus 2, and a remainder term. So that's my plus 2 divided by x minus 1. And now, where I started off with a rational function that might not have such an obvious antiderivative, I can take my antiderivative, this polynomial, lickety-split. So antiderivative of x squared is x cubed on 3. Antiderivative of x is x squared on 2. Antiderivative of 2 is 2x. And here again, I could pass this to a u substitution. I could say u equals x minus 1. My antiderivative here is going to be 2 times the natural log of the absolute value of x minus 1. And so that's going to be that part in the formula here, here. And then, as always, constant integration for indefinite integrals.